Welcome to the EthCC first edition of the ETH 1.x roadmap. Ethereum 1 is the chain that you know and love, and we need to maintain so that our network doesn't die. Are we excited? So basically, what we've done is Lane over here and myself, Boris, have pulled together a few bits and pieces to try and share what is happening with the ETH 1x roadmap, the Istanbul hard fork, how this all works, and what we think are some of the things that are going to go in. We're going to walk through this presentation. It's actually a slide deck that's in HackMD. Lane's done some edits. I did a few things. It's available. There may be edits from random community members in here because it's open to world writable right now. This is interactive. Please go ahead and put your hand up and ask questions as we go. We're going to try and be very explicit about, does everyone understand? Does anyone have any questions? And see where we get to. We're going to gather any questions that people have. So Lane and I know a small handful of things, but mainly we know who to talk to get answers to other questions and how to share them so that other people can help answer them. And use hashtag ETH1X on Twitter to ask questions. Yes, sir.
Is there a URL for this HackMD document that we can have?
If you go to the Ethereum Magicians forum, it is linked from there. And if you go to twitter.com/bman, my Twitter, it should be the second tweet from the top, right after a picture of a French pastry. Perfect. And Lane, L Rettig, 2 T's, will also tweet it again. Okay. Shall we begin? Thank you for the horns up there, Justin. So what is the ETH 1x roadmap is the guiding question for this conversation. This actually started, I would say, in the ETH Magicians gathering in Berlin, where one of the first times people said, what is the roadmap? Who's in charge of it? Where do we write it down? And that discussion has really continued from then with both ETH 1x and ETH 2. Why it's important, what are we doing, how does it tie into ETH 2, and who's responsible for it? So what are the upcoming hard forks? So Istanbul is the label for the hard fork that's happening this year in October. One of the things in scheduling the Istanbul hard fork was, hey, let's move to more frequent releases, let's do some planning, and let's do either 6 or 9 months. As far as I recall from the back and forth, the discussion was pretty much like, let's do 9, and then we'll see if we can do 6 for the next one. I don't think we're far enough in planning right now to know exactly where that's going to be. But what I tried to do is just think about, like, what is this stretching ahead? What does this look like? So at 6 months, so if we do one in October of Istanbul, the next one after that would be 2020, April, 2020, October. If we do 9 months, we're looking at July and April. I think this is one of the first times that we're actually, for me, it's super weird to put dates down like 2021, because that's clearly some sort of crazy future date. The 2020s? What even is that? I think this is where we'll probably get into some interesting questions. So May 17th, so all of these dates were picked to likely be either like a Wednesday or a Friday, like the projected date for the mainnet upgrade. That's a Wednesday, because clearly shipping anything on a Friday is a bad idea. May 17th is the next date that we need to care about, and it's not very far away. So it's the hard deadline to accept proposals, which means people have to write an EIP, an Ethereum Improvement Proposal, submit it to the EIP repository, have some discussion around it, and generally signal and saying, I'm planning on trying to get this into the next hard fork. July 19th would be the soft deadline for major client implementations. As far as we understand right now, the rough rule has been, if you want your EIP to make it into a hard fork, you need to have at least 2 major client implementations. So that's where that date would be critical. Mid-August would be actually doing an upgrade on one of the testnets, with October then being the projected date for mainnet upgrade. This originally came from a core devs call and ends up in the notes in the Ethereum/PM repo, kind of buried in a comment. So I pulled it out, and I've been maintaining a couple of pages on the Ethereum wiki for the Istanbul hard fork and other dates in the roadmap. So those are visible, and an easy one. Should be easier to get to than a long GitHub URL. Questions? Alles klar? Go ahead. Just wait.
So at soft, the major client implementations means it's already in and running, or like what would be considered it's in? That kind of makes sense?
Say it again.
Just keep going.
No. No, so it's a good question. It's a good question. So I think your question is, so
what defines as it's implemented so that it fits the requirements of being able to be put in?
I would generally say at the very least, you would need a pull request to the major clients. So code that works in the current version of a client that merges cleanly for the EIP that you want to do, right? So that would be in the Geth repo and the Parity Ethereum client repo, having a PR at the very least. Some of these are loosely undefined. So we're having this interesting discussion exactly around like, well, what does it mean? I even have a question of like, what does it mean to have a proposal? Could I just like quickly write up an EIP and be like, I wrote an EIP, can that go in now? So it's a process where we're actually tightening down some of these things a little bit.
And then just as a bit of a follow-up, who do you consider to be a major client?
I thought that I could easily get past some of these undefined things. In the past, major client might just get rewritten as Geth and Parity. Obviously, the Pegasus Pantheon client is quite robust these days, although I don't think it's running that much on mainnet yet. Kind of it essentially means not some random research client that doesn't really run mainnet ever. Yeah, that's what I'm saying. Fair? What's that? Well, it won't make it in if it doesn't run on mainnet. There you go. So if you quickly write a new implementation, maybe. Any other questions?
Yeah. Hi. So I just had a question related to testing. I know in the past, implementation of test cases has been a huge bottleneck. Under this proposal, would you say that it falls to the implementers ultimately to implement comprehensive test cases for proposed EIPs? Obviously, with help with buy-in from the testing team and help from people who have domain-specific knowledge in that area, or I mean, I guess, how do you feel about that?
So, one of the things I've done actually at that Istanbul page is there's a section at the bottom for proposals. A proposal I've made in there is that these dates should be extended with a security review. I think testing is another perfect one where having test implementations done. Whether we work together as a community and centralize testing, or we ask that the client implementations have tests that they can show have passed, is a good question. I would leave it open, but I would also probably put an asterisk in there that says, you know, the suite of tests that we've written for this EAP code passes on a regular basis. Does that seem fair as a way to do it?
Yeah, I would say that seems fair. I guess, and yeah, everything you just said seems good. But I guess, as somebody who's worked a little bit with testing and seen how when you only have a few people making the decisions and because testing isn't a glamorous job, the software can take, it may be hard for people outside of the small clique to participate. So I guess my point was that it would be great to get more testing, more community buy-in. Yep. I won't waste more time.
Yeah. No, so I totally agree.
Yeah. I mean, so currently, you want me to? Okay. So currently, how tests work is we write cross-client tests that are represented in JSON. And I mean, I won't go into the details of exactly how a test case works, obviously, but and then to actually fill the tests, meaning to actually to actually create the test cases, we need to use CPP. We use CPP Ethereum and specifically TestEth, which is the tool I was talking about that the testing clique has. That a select few are rather familiar with, and to the outside world is a black box, TestEth. And I mean, obviously, there's different kind. Those are only unit or state tests or unit tests, right? So there's fuzzing. I mean, that's kind of a high level. Yeah. Yeah, that's what these unit tests are. They're consensus tests for new features, but that's the state of testing right now.
Lane.
I also don't want to take over your talk, so please let me know if I'm like.
If this was a circle, I'd able to do a circle, I'd do that. So let's spell it out. Right now, there's a centralized Ethereum Foundation founded team that runs a single testing mono repo for all of the aspects of Ethereum. It is lightly connected to various specifications. Many pieces of Ethereum are underspecified, thus it is very hard to create tests, and very little of this is automated, and the skills to do this are in a very small group of people who mainly need to program C++ and some JSON. Is that about right?
I wouldn't say it's about programming C++. I would say it's about having an understanding of the quirks of the tools, and then having an understanding of the testing format. But yeah, it's very domain specific, very niche piece of knowledge. Right testing. It's not easy.
Can we, let's turn this into a question or ask for help, because a lot of this is just surfacing issues. And I'm going to say one of the things that we need to do is identify timelines and effort needed for testing. Is that a fair statement of summarizing? And we know that one of the things that is needed is more testing resources if we expect to ship more upgrades.
Yeah, I strongly agree with that. Whoops, this is way louder than I thought it would be. So my quick question, I mean, you said something, gentlemen, just, hey Jerry. One of the things you said that sort of really got my goat real quick is, how do you do a test on consensus via a unit test, right? Don't you have to be running a network with like a heterogeneous set of nodes to like actually determine if you're complying with the real consensus environment? Like, what does it mean to say that you've done a unit test on consensus? I see Jordy shaking his head angrily, and I would love to give him the mic so he could respond, because I just don't understand how that makes any sense.
I told you we needed more mics. Yeah. Oh, I'm supposed to not lead the lines.
I don't know if this will help it make sense, right? On one hand, we have a test suite that does test consensus within a simulated network. Yeah. I'm forgetting the name of this thing, but Peter actually wrote it. Hive. And that's one. I know that's being used for some things. Also, there's a new test framework being worked on by Python, by Piper. And there's a DevOps person helping them, a Nuge. Also, I know Casey, I'm not sure how much Casey is involved with that. Do you know?
Casey's involved with buzz testing. I know Casey Detro, he's been working with, there's a new grant person he's been working with on buzz testing.
Okay. So there are more resources being put to bear, but I do believe that they intend for consensus test in a simulated network involving more than one type of client.
Right, so I guess just mean like very completely
We are streamlining.
So I just mean very concretely, what does it mean to do a unit test against consensus, right?
I think the answer was the Hive environment where they do a simulated. It's not a unit test. I agree. Actually, I have a question. Is there a written down test plan? Okay, like, done. We've parked this entire thing. One of the things that we need to accurately make a network upgrade is have a written down test plan. Does everyone in this room have rough consensus that we would like a test plan written down? Any disagreement? Perfect. So Pavel, you don't want it written down? A plan for testing that is written down. I have a very low bar, Pavel. Oh, no, I'll put it better. Something that is written in a document that I can get to with a URL that does not end in a Gitter channel.
EEPs, not the EIPs, the EEPs.
What's that?
EEE.
The EEE, sure.
Yeah, from Peter. That has this written down.
Perfect.
It's more like coming with an answer, because we're building Nethermind as a following the major clients. The unit tests are actually unit tests because the way you test consensus is practically just checking if the hash of the next block is the same as expected. So you can define very clearly the test cases and see if you arrive at the same hash. The separate thing is checking if the branches are followed the same way. So if you split, and that's when you need some kind of testing of the network if everyone knows the same blocks from the block propagation. But the unit tests are really there, and they were super important. And whenever we have a hard fork, like for us, following the major clients like GAF and Parity, this date of having the tests to run everything, this unit test to be ready, is very important to see how if we are ready already or not.
Perfect. So, we can hear Rick.
I'll move down, right? That solves this whole problem. So so it sounded to me from your description that you were running 2 separate unit tests with the same data in 2 different code bases, right? Okay, so that, again, not to be pedantic, but that's not a unit test, right? That's, yes, in 2 different test suites. So that is the answer to that question, right? You weren't using one code base to verify. I mean, this is like a semantic thing, right? If we have multiple clients and we're trying to get consensus across multiple clients, then we necessarily must be running multiple tests to get that consensus confirmation. Right? And that has to be, and I'm just mentioning that in this very pedantic way because it goes into the test plan, right? When you do a release, you can't just say, oh, we got internal consistency in our repo, so we're not going to fork. Okay, so you're not going to fork from yourself, that's awesome, but there's other clients and you need to have some sort of cross-test across those repos to show that they're not going to fork as well. Like that there's going to actually maintain consensus across the clients. Yeah, okay, yeah, thank you.
That was awesome. I'm going to go to the next slide. Okay? I'm publicly signing us up, Alex. So 233 describes the formal process, as has just been discussed, from maybe making sure that there's a test plan. Alex and I talked a little bit that that likely could use with some upgrades. So the EAP process is where we write down what our plans are and how they work. And so this EAP 2 through 3 you can visit, has the details right now. Alex and I are going to do some work to look at that and improve it and implement that as part of this next Istanbul hard fork process. Did you want to add something about this right now? No? Good. We will do work. Signaling. EAP 1679 is the Istanbul hard fork meta IP. So it's the placeholder that says these are the details around Istanbul. One of the changes that Alex and I are going to propose is that ahead of the hard fork, anyone who intends to propose an EAP makes a pull request against that meta EAP, and we initially place it in a propose section. That way we can track changes through GitHub and use the processes that we already do and make very visible which EAPs people are committing to work on. Very roughly, this is the process. So propose an EAP, and the way to propose an EAP is to go to the EAPs repo, take the markdown template, fill it out, submit it, get it into draft mode. Draft mode is only about making sure that you have the markdown correct, and some light checks to say, yes, this is the right format. Get them to last call, implementations, bring them to core devs to move them to accepted, signaling that they will in fact make it into there. I put the piece about implementations in at least 2 major clients in that sometimes code gets written as part of the process of proposing EAPs where there is some code in flight kind of in parallel with some of the rest of this process. Does this make sense? Did I get something wrong? Does anyone have something to add to this outline? Awesome. Now we know how to make EAPs. This January, end of January in Stanford, there was a core dev meeting. About 30 or so people attended, I think, organized by Joseph Chow from Consensus. The 2 major topics were state fees and EWASM. On February 6th, I helped host a webinar where we went over some of the things that came out of that Stanford meeting. There is a really great video of that discussion that is a really good way to get up to speed with a lot of these topics. We asked a bunch of questions, and I think it was a pretty good format. And in many ways, what we're doing here is doing the same thing again so that people have an opportunity to ask questions. So definitely look at that. Alexei, also responsible for TurboGeth work, has taken the lead in research and planning on state fees. As we know, or perhaps you're learning from me in the first time, is Ethereum state is growing to unmanageable sizes. And it's going to hit a critical point in about 2 years. Critical meaning that nodes will have trouble syncing because of the size of the state. Yes, nodes currently have trouble syncing. 2 years from now, they reach some theoretical limit that will most definitely not link. That 2-year estimate is based on kind of eyeballing, well, this is how many people built dApps and built dApps in a particular way, and this is how many new people. So if we think that more people will continue to build on Ethereum in ways that use state in the way that they have in the past, we may have less time. But we'll have lots of new users. Good news, bad news. There are better images of this, but I just wanted to pull this in. Look at Alexei up there with his little mop head. He's amazing. What Alexei did is initially, I caught a glimpse of this chart, and I said, that is the most confusing chart I've ever seen in my entire life. And then I actually read it, and I'm like, oh, this is a really good way to represent this. So Alexei has, proposals are in flight, but basically has a bunch of different components that go into upgrades to Ethereum, to the protocol, to how things work in order to make some fixes around state fees and pruning. So what he then did is decomposed it and said, which of them depend on each other? Which of them can we do in parallel? And which of them do we have to implement in a hard fork? And then we have to wait for that hard fork to pass, and then we're going to have to do another hard fork. So what he came up with is a potential timeline that implementing state fees will take 3 hard forks. What you'll now see, this loops back around to our timing for hard forks that take either 6 or 9 months. So that way we can tell how long we have to implement all of these things. Does that make sense? And as you can see on the side there, there's a whole, Alexei's got a whole presentation around this where he walks through each of the proposals. Without Alexei in the room, we can't go into the details. I recommend watching the video. I recommend reading the presentation. The place where we have this slide deck linked on ETH Magicians is a great spot to add questions and also answers. Okay? Is there anyone in the room that wants to say a few words about state fees in more detail?
No.
Oh, just Epicenter recently did an episode with Alexei, and he went all over this, and it's a great resource as well.
Perfect. The Epicenter podcast.
Yes, I'm plugging my own thing here, but yes.
Great. If we can make sure that that gets linked into this forum thread, that'd be fantastic. Yeah. Great.
Yeah, just really briefly, it's a fairly controversial topic. I don't completely get why. I mean, I get that people feel that maybe there's some implicit social contract whereby you deploy something to Ethereum and you expect it to always be there. That's really nice, but it doesn't matter, right? Because it's an existential question, right? And like nothing else really matters. If we don't fix this and Ethereum dies in 2 years, like nothing else really matters. So we need to fix it. It's really important. Get on board.
Hi. So for state fees, I understand that the kind of the necessity is that we don't have a chain that's kind of like just filled up with I don't know, probably things that have been deprecated. But it introduces kind of a new question mark in development by having state fees, and we can seriously break some of these contracts that are reliant on other contracts, and kind of ruin some of the guarantees that came from static analysis of the contracts beforehand.
Yeah, I believe state fees represents basically a change in the user agreement. And I believe it represents a new series of Ethereum. Maybe not as dramatic, obviously, as 2.0, but I feel like state fees is 1.0, and what we're on right now is 0, right? And if you can see, like, all of what it requires, all the steps, I just think it's so big. This isn't an upgrade. This is a whole new series of Ethereum that makes Ethereum sustainable until we get to 2.0. I mean, that's just my general impression about it. I want to see if people feel that way, if it's on that level.
2.0 still depends on the main chain running into the future.
Yeah, being that 2.0 requires the mainnet, I'm hoping that mainnet will be active when 2.0 comes around. Because what's going on right now with finance, there's going to be some new apps that take off. And is it going to be as big as the ICO phenomenon? I hope so, because that's activity, that's success. Will success generate conditions that make it happen faster than 2 years? That's what I want to know. I don't know how to predict that.
Someone please correct me if I'm wrong, but my understanding is the beacon chain depends on the main chain running and will continue to depend on the main chain running into the indefinite future. So when 2.0 arrives, 1.0 does not go away unless the spec has changed since the last time I studied it.
My understanding is the only place where the beacon chain relies on ETH1 is just transferring Ether unidirectionally from main chain to the beacon chain. So in that sense, it does, because you have to be able to move value over from ETH1.
But unless ETH has value on the main chain,
yeah. If ETH doesn't have value on the main chain, what's the point in, yeah, I agree with that.
I think we're going to have the deposit contract, but we will depend on one for those deposits until we hit the state execution phase, which I believe is phase 2, which would be bringing eWASM online. We can't, we obviously can't dynamite the ETH1 chain, right? We don't have kind of like that level of control, so it would continue to exist indefinitely.
Yeah, I second that. That's why we're here, and that's why ETH1X is a thing, right? Because we all recognize that we have to keep Ethereum alive in some form, right, until we have ETH2. 2 more really quick points, especially in response to your point, Joe, and then I'll give you back the mic. The first is I agree wholeheartedly with what Jamie said a moment ago. Like, Ethereum is in beta. I'm sorry. I'm sorry, but if you built something, and it blew up, and there's a lot of value, and people are relying on it, it's a beta product. It's always been in beta. And we need to get it to like a 1.0, and it's not a 1.0 until it's stable. So if you have to make breaking changes, I'm sorry, but you have to make them. That's the first point I want to make. The second point is it's never been contemplated, as far as I know, making, how do I put it, like even if we do state fees, if we start removing contracts or accounts, they can always be restored. I want to be very clear about that. That's part of Alexei's plan. Accounts can always be easily restored if they're cleared, if the dust accounts are cleared, which is part of the plan. And contracts can also be put back in place, even if they're cleared, okay? So that nothing's going away permanently. There's still immutability in a sense. You can still replay transactions, and the stuff that was there is always there. It's just, what's your definition of immutability? That's all.
A totally non-controversial topic. Yeah, so I think that's a really interesting one. So again, just echoing that state fees you know, there's a ton of my first DApp things that are sitting around taking up space. There's a bunch of calculations around what exactly is on there, what's stale. There's already some estimations of things that haven't been touched in years that would save this much space, and those are the ones that are targeted, and they can be revived or rehydrated in certain ways. And this multi-plan thing slowly goes down, adding these things until the very end. We know what the variables are at time X since account contract Y has been touched, then we will dehydrate it and we will rehydrate it again. You know, there's already changes in language to try and make it clear to people that this isn't as scary. I think what Lane is saying, we really want to make sure that people understand why this is being done, that it's important, that it gets us to a space of sustainability with ETH1X running essentially forever. And that's the reason, and we want people to be engaging and asking questions now so that they're comfortable with these changes as they come. Make sense?
I realized that I was misunderstood, Greg. I think that Ethereum 0, Ethereum and Ethereum 1 will continue to run long after Ethereum 2 is released. So that's just my thinking about it, is that what we have now there will be people that want to keep that running. So we upgrade to this, to Alexi's proposals and at 1x, and then that will keep running. And I'm not sure how you deal with that in terms of the cryptocurrency, because now we have 3 cryptocurrencies.
So I'm a little lost on, maybe I just zoned out for a second as to how we get to 3. I counted 2 very clearly there, the Ethereum 0 where we're at today, and then you're saying Ethereum 1 is Alexi's, and then that has its new token, and then we have a 3rd token when we go to 2. Okay, so my concern in the narrative that you just described is there's no clear, what is it that binds a DApp? So let's ignore the existence of developers for a moment because they're DAOs and what have you, yada, yada, yada. So let's use the DApp as the construct. What is it that's going to bind the DApp that was written in Ethereum 0 to Ethereum 2? Like, why are we talking about why don't we call it like Happy Monkey Chain if there's, what's the relationship? And I think maybe like a high-level meta thing, I think that we're all here basically because of like memetics, right? Like we believe in the Ethereum narrative. And so if the only thing that, literally the only thing that carries over from Ethereum 0 to Ethereum 2 is the narrative, that may be sufficient. But we're also a room of mostly engineers who probably find that revolting, right? So there has to be something actually binding the user, the DApp, from one network to the next network to the next network. And if we're not making these additional network supersets, right, if we're not actually having the entire state of Ethereum 0 represented in Ethereum 1 and the entire state of Ethereum 1 represented in Ethereum 2 as like a shard or what have you, we're in a kind of almost, we're making a crisis out of for no reason. So I think that we should, in these sort of discussions, we should be considering this as an alternative or as a hypothesis.
I think that's a big thing where I haven't heard from the ETH2 plan a concrete statement on this, but as I understand it, the ETH1X becomes a shard in ETH2, where it has the same issue as all of the other ETH2 shards of question mark around cross-shard communication. Is that a fair and accurate way of saying it? But it's undefined. That's, yeah. Okay. Go ahead, Greg.
Someone tell me who knows for sure, is it going to become a shard? That's new to me.
Yeah, so we're still, I should say, it's still being figured out. It's a bit of an open question around exactly what happens to ETH1 after ETH2 is running and we're past phase 2 and it's usable, it's creating value, et cetera. I've heard 3 concrete proposals. And this comes mostly from Danny, who also spoke about this on I think it was the Zero Knowledge podcast recently, so listen to that if you want to hear it from the horse's mouth. The first is we just leave the existing Ethereum chain to run and do its own thing. It doesn't cause any harm as long as we are able to continue to finalize it. So the first thing that's going to happen in phase 0, the first piece of value that the Ethereum 2 gives us, the beacon chain gives us, is it's going to be finalizing Ethereum 1, which is pretty exciting. And so if Ethereum 2 is able to participate in the security and finalize the blocks on Ethereum 1, then what that means is we can drastically reduce issuance. Okay, that's the key requirement. If we're able to drastically reduce the issuance on ETH1, then we can leave ETH1 to just do its own thing, and nothing else needs to change. That's the first option. The second option is it becomes a shard, as Boris said, with all the challenges that would go along with that. Now, the complaint against having it be a shard is that it would be different from all the other shards in one special way. It would be running a different state execution engine, which may be kind of messy. And so the third option that's on the table is somehow, right, the details are a little fuzzy, capturing all of the existing Ethereum chain and putting it inside a smart contract on a shard somewhere on Ethereum 2. Those are the 3 options on the table. Does that help clear things up?
Yes, and absolutely something that we want to write down so people can read it. Perfect, thank you.
So just briefly, unless, as Rick said, by some way, either by moving or surrounding, it's possible if you have, possibly one business I'm working in intends to build a $1 billion system on Ethereum. If they are not able to move their $1 billion system easily onto ETH 2.0, and there will be other such, ETH 2.0 basically is a completely different thing, and the only thing it really has in common with ETH 1 is that it owns the Ethereum trademark.
That may very well be the case, but I think that's exactly what Rick was saying.
I just have a question about the schedule, the forks. The narrative I've heard is 1 fork, 2 fork, ETH2, and I'm seeing fork 1, fork 2, fork 3.
This is the ETH1X chain. It has nothing to do with ETH2.
Right. That ETH1 has 3 forks, and then we move into ETH2 land, or is are all those?
These are the 3 forks to complete Alexi's state fee implementation. At that point, the Ethereum chain is sustainable and can run indefinitely without blowing out state.
So then what I've heard of narratives is us having 2 forks and then ETH2 shows up. But that seems incompatible with that. That's where I'm trying to get clarification.
So there are no dependencies of ETH2 on ETH1.
Not technically dependencies, but the narrative that we'll have one release, another release, and ETH2 is coming in 2 years or so, or something like that.
It's unclear how long the roadmap is for ETH2.
Again, no dependencies upon ETH1 on the part of ETH2. They happen in parallel. We don't know how many hard forks there's going to be in ETH1, but again, ETH1's going to, we intend to keep it alive as long as necessary, so I would say it's probably going to be more than 2. And one more thing, while there's no dependency on ETH1, we actually state rent, state fees, whatever you want to call it, is a great example of one of the pieces of research that 100% applies to ETH2.
Yeah,
and so the hope is that this would be rolled in ETH2 as close as possible to the form that we're figuring out for ETH1. Exactly. Does that make sense?
So we need to fix this for ETH1, and this exact same thing gets implemented on a per shard basis, right? So it's more like the other way around. Oh, we've got this running network that runs today that we need to fix, and it turns out that research and work is forward compatible, which is a word I'm going to start using to make people feel less freaked out, with future work that we're doing on ETH2 as well. Shall I move to the next slide? Yay! Ethereum flavored WebAssembly. Insert lane. Would you like to come down here and read this slide?
Like you said, the link is public, so I hope Dean or someone hasn't gotten in and trolled us and changed things. I threw this together really last minute. I'll breeze through it. I know most of the EWASM team is here in the room with me. I don't know if you guys had a chance to look at this, but like literally just raise your hand if I got something wrong or left something out, because I want to make sure this is accurate. So super brief background. The project was initiated in, is this right, Alex, 2016? By Martin Beasy, originally, who went on to build this really exciting execution framework called Primea for the Definity project, built on the early work. In parallel, Alex and a bunch of us have been working on EWASM within the Ethereum Foundation. It was originally intended, so we've kind of come full circle, which is kind of cool. It was originally designed to be rolled out on the mainnet. And then we found out ETH2 is coming, Serenity is coming, and the idea was let's push all the innovation into ETH2. And then we found out in June that ETH2 is going to take a bit longer than we expected. So now we're kind of full circle, and now EWASM is back on the table for ETH1 as part of the ETH1X roadmap, which is what we're talking about. EWASM was originally a passion project, a side project that Martin and Alex were working on, but as of about a year ago, we have a proper team with 9 people on it, I think 6 or 7 of which are in the room here so we can answer questions. The biggest milestone to date is that we launched a public testnet at DevCon last year, and we did a big workshop there, which is very exciting. So is our testnet running? I don't know. It should be. It is. Thank you, Jared. So you can actually, so this leads into the next point. You can actually use the tooling we've released. If you go to github.com/EWASM, write contracts in languages like C, C++, Rust, compile them to WASM, and deploy them and test them on our testnet today. And if you're a forward-thinking project and you want to be building for ETH2, that'd be a good thing to begin testing because EWASM is very likely to be the execution engine for Ethereum 2. High-level goals of the project. Making precompiles great again because, as you've probably noticed, we haven't added any precompiles in quite a while. We want to be able to do more advanced cryptography, elliptic curve, math, that kind of stuff, and EWASM makes that a lot easier. It allows you to write smart contracts in a whole host of languages like Rust, which is really exciting. Thank you. We have a bunch of open questions about the project, so here's a few of them. Interpreters are easier and safer, and we have them running. So the testnet today is running I think it's only running Geth, is that correct? Right, with a WASM interpreter called Wagon. However, the whole point of EWASM, if we want to deliver better performance, we need it to be compiled, whether it's ahead of time or just-in-time compilation. But that raises questions about pieces of code that may cause compilation to take a long time. We call these JIT bombs, right? And we haven't solved that problem yet. So there's an open question. Do we need to write our own compiler? Is there an existing compiler that works? How do we do gas metering? We have, again, each of these is a deep topic. How do we get EWASM onto the mainnet? So one option is, as I said before, we deploy this maybe as part of the ETH1X roadmap as a sort of final precompile or one precompile to end all precompiles, which is to say that anyone could then deploy user contracts. Instead of needing to add more precompiles, we could replace existing precompiles with EWASM-based precompiles. We could meter native code precompiles using WASM. We have a whole host of reasons which Alex walked through in great detail in our session this afternoon. So look for his talk if you want way more detail on that. EWASM is on the roadmap both for ETH1X as well as ETH2, and so we have some questions in our team about our own priorities and can we do both in parallel, and do we want the same approach or different approaches? Which languages do we want to support? So we're looking at things like Rust and C, C++, and maybe this cool thing that looks like TypeScript called AssemblyScript. So I'd love to hear from you guys about which languages are most exciting. I think that's, oh boy, okay. Yeah, limited time. If these are interesting, if you have questions, if you want to dig into these, we'll do that in a sec. I think this is my last slide on EWASM. Yeah. Boris says, we need to prepare a similar hard fork timeline to what he showed you, Alexei's state fees plan. I agree. That would be great. Let's work on that. We need to solve some of those questions before we do that. Right now, we're doing a lot of amazing work on benchmarking, right? Understanding the different performance characteristics of the interpreted WASM versus the compiled WASM, of WASM versus EVM, of different compilers and different interpreters. Jared gave a really great presentation also this afternoon, which you can also look for based on a lot of work done by Casey and a couple of other members of our team on benchmarking to understand what our goals should be. So yeah, we need to figure out how to get this into ETH1X. We need to write some EIPs. That's on the table. You know, I don't know. I pulled these numbers out of thin air, so feel free to disagree. But we need to, yeah, so hopefully, right, we'll hit targets of kind of roughly Q3 this year, being ready to launch the first eWASM into production on ETH1X. And of course, in parallel, all the ETH2 stuff is happening as well.
Questions?
Or corrections or additions.
So I'm not amazing with compilers. What are the constraints on what languages can be made available to compile down to eWASM? Like, why some languages, not others? Like, is it just more work? Are some languages not appropriate? Like, I mean, I'm just curious how that works.
Anything with that plugs into LLVM, any language with an LLVM front end can be compiled to WASM.
Yeah, and I would add probably, so the broader answer is tooling, right? What tooling is available? So some languages, I think we've had experiences with like Rust, for example, or AssemblyScript is a good example. Actually, AssemblyScript compiles down to really lean WASM, which is great. I think Rust, by default, compiles down to very large WASM binaries, and so you need to do certain pragma things to like remove standard libraries, things like that. It's mostly a question of tooling.
As a dApp developer, like, and I want to build something in eWASM, am I going to have availability to like every LLVM language to write contracts in?
I think the short answer is yes, but the slightly longer answer is someone needs to write the tooling for each of those. So we have a quasi-official set of supported languages, which I think at this moment is C, C++, which Paul's done a lot of work on, and Rust, which Alex and Jake and a couple of other people maybe have done a lot of work on. I've done a little bit of work on AssemblyScript, which I'm excited about. So pick your favorite language and help us write interpreters and compilers and tooling, basically.
Awesome. So if I understand, then I can write kind of like you know, very like rudimentary C++ contracts right now using eWASM.
Yes, Jake, do you want to talk about writing eWASM contracts in C++? Grab that mic. Is that a? Okay, the answer is yes, you can. Talk to Jake. Oh, straight.
Yes. Thanks, community. I have sort of a noob question just about performance. So how much better is the eWASM performance compared to current EVM performance?
Jared just did a presentation on this. Do you want to talk about it for a sec?
Well, okay, so yeah. So for how to put this? So for it isn't as good. WASM to native performance isn't as good as, say, like for example, I think Cloudflare. Geth uses Cloudflare's implementation of easy pairing, which is like handwritten assembly. So it's not as good as stuff like that. It's not quite as good as the native code or the native precompile implementations at the moment. So, but it's within the, for most precompiles, it's within the range of, I would say 1.5 to 2 times as slow, which sounds really bad, but just remember that I would say it's not, at least in my mind, it's not, it's not about performance. Mostly, it's about, well, I know that's a terrible statement at face value, right? But if we can get the performance close to good enough as the current precompiles, and it's more about being able to put more cryptography on chain without increasing burden on the testing team.
I second that. Performance is not the main goal of the eWASM project. It's exactly what Jared just said. We want to make it easier to do stuff like complex cryptography on chain, basically.
And just to like, I'll pass this to you in a sec, Jamie, but just to explain my last statement, I think it puts and the reason why it takes the burden off of the testing team or some of the burden off of the testing team is it takes the, so currently the different implementations all have to be correct, and they all have to have test cases to describe all the edge cases of the behavior. Whereas we move a level lower and assume that the WASM engines and are implemented according to the spec, and that we are kind of dipping into this wider ecosystem to ensure correctness.
Okay, let's move on.
I have one question. So my question is, WASM for 1x is, the proposal is just for precompiles. It's not for dApps. Am I getting that correct?
Lane? So the question is, WASM for 1x is just for precompiles, not for dApps?
I think we should let Alex take that because there's been some back and forth on it.
Okay.
What am I talking about?
Okay, so like, is WASM for 1x, is that just for precompiles, or are you also going to allow dApps to use it in a different way?
I mean, ideally what we would want is to have everything. And the proposal is the multiple variables in the system, right? So one variable is the interfaces exposed to WASM, and the number of interfaces exposed. To have like a contract, the EVM itself exposes over like between 20 and 30 individual features to the state. And you want to have the same number of features exposed to WASM if you're writing a contract. Now that number goes down significantly to roughly like 4 or 5 items if you only do precompiles. And you can add a lot of like features on that level. On the other side, you also have the risk and complexity of any code which might trigger issues in compilers or may not fare well with interpreters. So judging like these two factors is the reason we have been looking a lot into considering precompiles for ETH1X. And the benchmarks kind of show, that's kind of like going back to the previous question on benchmarks. And I think the real question to ask may not be how does it compare against current precompiles, but also how does it compare against EVM. And we have done benchmarks between EVM implementation, hand-optimized EVM implementation of the same code, like hashing algorithms, versus having it not hand-optimized in WASM. And we got, depending on the algorithm itself, like between 5 and 30x speed advantage to the WASM version. Now what Jared was saying, compared to like the really performant, hand-optimized precompiles for crypto, in that case, like the WASM, interpreted WASM, doesn't really fare that well. It's lower. So what I'm getting at is we have like 2 different targets. We can look at precompiles which go well with interpreters, and we can go look at precompiles which go well as being compiled. And we are trying to address like both cases, and we're still in the process of having like good guidelines, which one we suggest, or it's ultimately not only us deciding it. What we want to do is like getting all this data right, writing all these different proposals. So these are the pros and cons for each of these, and the wider ecosystem has to decide.
Awesome, thank you. So starting at Berlin last year, a group of people started working on kind of a label called EVM evolution. So improve the EVM, support the EWASM team with forward compatibility. Again, what changes can we make? What is it going to look like in the transition? That's been, a large chunk of it has been Greg, my co-founder Brooklyn, and myself. We've got an outstanding application for an EF grant. Greg and Brooke, who are co-authors, have proposed EAP 615 for the Istanbul hard fork. This helps a lot with security and static analysis, so we've had a lot of support from the Trail of Bits team, Consensus Diligence, and the secure ETH community who are excited about this, and other people who are fans of formal verification and static analysis. So certain classes of things are improved here. As part of this as well has been an increased focus on improving and maintaining the EVM specification with the Jello paper and formal verification. So as an example, we don't yet have the Constantinople EEPs formally specified. That's another proposal that I'm going to suggest, as part of this next hard fork, that we get those specifications done before the hard fork activates. I have contacted Alexei to see if these dates work for him, as he's a major lead with state fees. I'm announcing this now, and I'm just working on planning from a core dev meeting in Berlin. I believe that we need to set aside time that isn't ad hoc at conferences, much like the January Stanford meeting, to have planning to improvements to the network as dedicated and priority time rather than fitting it in around conference travel. We've got a bunch of other questions around funding, testing, security reviews, if we want to improve the process to add more security reviews or security audits. How does that scheduled and how does it get funded? Are the people who create the EEPs responsible for it? Open discussion. We're very close to the end of our time. 4 minutes. Other questions, comments?
Could you list out the benefits of EVM evolution just to dApp developers?
So it's more of a matter of right now, there's people building dApps, building smart contracts on the network today. EWASM, full support for dApps. Let's just say it's going to be a while. I don't think we're going to have dApp support in this next Istanbul fork. Alex? Smart contracts written for EWASM by... It's unlikely that we're going to have that. Therefore, let's continue improving the EVM for security and performance, again, with the understanding that it keeps going. You can also use the LLVM with the EVM. So we can support lots of other languages if we want to. We've been talking to Microsoft Research and Intel and many others who, in fact, use the EVM and are very excited about the EVM. If we were starting today from scratch, WASM would be the likely choice. Actually, the other thing to mention about WASM that just came out from the last couple of days, so several people have been independently reaching out to the essentially upstream WASM, the group that's creating the specification that everybody uses for WASM, and they're very interested in having the Ethereum community participate. So part of that is working on those upstream specifications as well. So all of this work is going on in parallel and needs to be done. So we need to keep improving the EVM. We can see real gains today while making sure that all of these things get pulled into EWASM research, and which applies to both ETH1 and ETH2.
I just wanted to say about ETH2, I wanted to dispel a myth that I've been hearing a lot lately. It's not around the corner. It's going to be a while. We're hoping that there's going to be a beacon chain like late this year or maybe early next year. But we still don't even really understand how far it's going to be on the roadmap. That's step 0 of the 3 phases. So yeah, the need for ETH1X is very real, and I think it plays into both.
Shall we end it there? I think one of these things is a call to action, really, at the end of the day. There's been lots of back and forth on this. Let it be clear, everything that we do right now, the growing open financial, DeFi, DopeFi ecosystem, all of it is running on the chain that we have today. We need to keep working on it. We need to keep funding it. We need to keep making it secure. That's why we're all here. So I encourage people to get involved, to watch the process, to hold various players in the ecosystem accountable for stepping up and making sure that all of this succeeds with necessary resources. I look forward to seeing you in the Ethereum Magicians Forum and elsewhere in excellent open source code. See you on chain.